Okay, the new part of today is what's called the rational zero theorem. So yesterday, we went through that example of finding all of the zeros of a polynomial. We're still doing that today. That's our kind of end goal is I give you a polynomial function. You find all of the zeros using any of the methods that we've learned. But remember from yesterday when we were finding the zeros and making the tables, there was a method as to what x values we were trying, but we were basically just trying any x value. So I had suggested substitute 0 in first, and then start with positive values, and then switch and then try negative values, but it was any number. The rational zero limits what numbers you should actually try plugging in. So rather than plugging in 1, 2, 3, 4, 5, maybe from that list you shouldn't even try 3 because it's not on the list. So that's what we're going to go through first, is just how to come up with those possible rational zeros, and then we'll actually use it in the example on the back. So our first goal is just to identify what the possible rational zeros are. And remember that a rational number is a number that can be expressed as a fraction. So the rational zero theorem states if p of x is a polynomial function with integral coefficients, so the coefficients are integers, then every rational zero of p of x equals 0 is of the form p over q. So a rational number in simplest form, where p is a factor of the constant term and q is a factor of the leading coefficient. So the numerator of the fraction is a factor of the constant term in the polynomial function. Q is a factor of the leading coefficient. That would be the denominator. So it does give a specific example there in the box, so we're going to go through examples as well. And then what it says for the corollary to that theorem, this is just a special case, not necessarily anything different. This just says that if the leading coefficient is 1, then any rational zeros are factors of the constant term, because the factors of the leading coefficient are the denominator. If the denominator is just 1, then we know that that fraction is just the whole number. So we're going to go through example 1 together so you can see how to use this. So it says list all of the possible rational zeros. So just making a note when the directions say this, what you should do. You're not actually finding all of the zeros, you're just listing the possible rational zeros. And for part A, so f of x is 3x to the fourth minus x cubed plus 4. Our rational zeros are going to be in the form p over q. And again, from the rational zero theorem above, p is a factor of the constant term. The constant term in the polynomial is the term without a variable. So in this polynomial, it's 4. So p is going to be a factor of 4. And then q is a factor of the leading coefficient. And what is the leading coefficient in this polynomial? We've talked about leading coefficient before. 3, yep. So since 3 is the leading coefficient, our q is going to be a factor of 3. And factor, so a factor of 4, a number that would multiply to be 4. So I'm going to list after each of these what those factors actually are. So what numbers are factors of 4? What numbers multiply to equal 4? I heard 2 and 2. So 2 is a factor. What else could you multiply to get 4? 1 and 4. And I'm just going to list them in order. So 4 only has 3 factors, 1, 2, and 4. And then what are factors of 3? 3 and 1, or 1 and 3. All right, so coming up with our actual list. Now in this list, any of our numbers could be positive or negative, since a positive or a negative is going to go into or could be a factor of a number. So in front of each number, I'm going to include plus or minus. And this is typically how I work through it is my numerators all have to be factors of 4, so 1, 2, or 4. My denominators all have to be 1 or 3, factors of 3. So I usually take all of the factors of the top and put them, in this case, over the 1 first, and then I would take all of the factors of the top and put them over 3. So If I take 1, 2, and 4, and I take each of those and put them over 1, any number over 1 is just itself. So 3 of my factors are going to be plus or minus 1, plus or minus 2, plus or minus 4. So all those would be over 1, but then they're just simplified, just 1, 2, and 4, and again, plus or minus in front of each. And then I would list each of those factors of 4 over 3. So I would have plus or minus 1 over 3 is 1/3, and leave it as a fraction. And then plus or minus 2 over 3 is 2/3. And then plus or minus 4 over 3 is 4/3. So I've taken every factor of 4 and written it over every factor of 3. So this is my complete list of the possible rational zeros. Now, how we're going to use this, and we are going to do this today, how we're going to use this on the example on the back is these are the only numbers when you're making tables that you should choose from to try and plug in. So if I were plugging in numbers to try to find a 0, if I say started with +1 and then +2, I should not plug in +3 because this list already tells me it's not going to work. So that's how this is going to be helpful to us. We'll use that on the back. What I would like you to do, though, is do part B, so find the possible rational zeros of that function f of x. And then we'll make sure we all have it before we move forward. Right, so that, yeah, the negative with the 15 doesn't really matter since all of your factors are going to be positive or negative. So you don't need to include the negative. right, I think we all are good. But just double check what you have. This is what I saw in most of yours. If you have them in a different order, it's fine. But because your leading coefficient is 1, this is what that corollary says, is that your possible rational zeros are just the factors of your constant term. And make sure you do include the plus or minus. So this really is 8 values when you consider all the positive and all the negative. Okay, are there any questions on just this before we move forward? Okay, and we are going to be using this in the next example. So this is where if you had questions from finding all of the zeros from yesterday, hopefully this helps. You will have time at the end here today to work, so let me know if you still have questions on it. But question is just find all of the zeros of this function k of x. So I am going to work through the steps that we worked through yesterday. I'm going to include or add in finding the possible rational zeros from today, and then find the zeros. So first of all, just in looking at the polynomial, how many zeros should there be? 4. And why should there be 4? Degree is 4. Okay, so that's just helpful to know ahead of time how many answers should I have. I should have 4. So although I know I did say this step I'm going to do next is technically optional, I'm going to go through this step again today of finding the possible number of positive real zeros and the possible number of negative. Just so when I'm actually trying to find numbers, I have an idea of how many positive or negative real zeros I could have. So I know this part can be confusing. I want to explain it again. The possible number of positive real zeros. So in looking at the function itself, you find the number of times the signs change from one term to the next. So for k of x, we start out with a positive 2x to the 4th. The second term is a negative 5x cubed, so that's a sign change. And then from the second to the third term, negative 5x cubed to a positive 20x squared is a sign change. Third to the fourth, positive to a negative term is another sign change. And then negative to a positive constant, that's another sign change. So there's 4 sign changes. That means there could possibly be 4 positive real zeros, or 2 less than that, so or 2. But then we could also take 2 less than that, so then it could be or none at all. So we could have 4 positive, only 2 positive, or no positive real zeros. And that's just the possible number of each. Okay, and then the possible number of negative real zeros. To find that, we need to find k of negative x. So the function, if you substitute negative x in. And again, I explained this shortcut yesterday. So since when you raise a negative to an even power, it is a positive. So any even powered term, the sign will stay the same in front. Any negative to an odd power is negative. So any odd power term will change sign. So positive 2x to the 4th will stay positive 2x to the 4th. Negative 5x cubed, since it's an odd power, will change to positive 5x cubed. Positive 20x squared, even power, will stay. Negative 45x, that's an odd power of 1, will change to positive 45x. And the constant doesn't have an x, that will always stay. And you find the number of sign changes here to find the possible number of negative real zeros. How many sign changes do we have? 0. This is a case where this step is the most helpful because I know that none of my real zeros are negative. So when I'm actually plugging numbers in, I shouldn't bother plugging in any negative number because it's not going to work. Correct. For the positive real. So the rule says that the possible number is equal to the number of sign changes or is less than that. It says by an even number, which I said was 2. So you find the number of sign changes, and then you keep going down by 2 until you either reach 0, or say you reach 1, because you can't go down by 2 without becoming negative, so then you would stop at 1. So you keep, 8, 6, 4, 2, or 0. Yep. Okay, and then I'm not going to find the possible number of imaginary. This is the part that's most helpful for this type of question, because we're not trying to plug in imaginary numbers, we're trying to plug in real numbers. So I'm going to stop here, but then I am going to find the possible rational zeros. So what we just did on the front examples, I want to come up with the list of possible rational zeros. The P over Q. Actually, I shouldn't have written that. So in this case, P should be a factor of what number? 18, our constant. And Q is a factor of the leading coefficient 2. So what are factors of 18? 2 and 9. I'm going to try to write these in order. So 2 times 9 is 18. 1 times 18. And then, 3 times 6. So 1, 2, 3, 6, 9, 18. Again, if you don't have them in numerical order, that's fine. Just me personally, I try to write them that way. But if you don't have it that way, it's okay. And then factors of 2 are just 1 and 2. So my possible rational zeros, I'm first going to take every factor of 18 and put it over 1, which is just going to keep all those numbers the same. Now I could put plus or minus. Instead, I'm just going to write the positive numbers because I've already determined a negative number isn't going to work. So I'm just going to write the positives for this one. So I have 1, 2, 3, 6, 9, and 18. That's all of those factors over 1. And then I need to list all of those factors over 2. And now if, when you simplify a fraction, you get a number that's already in your list, you don't have to write it again. If you write it twice, I'm not going to take off for that, but you don't have to. So 1 over 2 is 1/2, or you could put 0.5. 2 over 2 is 1, and that's already in my list, so I don't need to write it again. 3 over 2 is not in my list. If you put 1.5, it's fine. 6 over 2 is 3, that's already in my list. 9 over 2 is 4.5, so that's not in my list. And then 18 over 2 is 9, that's already in my list. So these are the possible zeros. So in my next step, when I'm actually trying to find a zero, I should only try numbers from this list. Any number not in this list is not going to work. That's why this step is the most helpful. So now we're actually going to find the zeros. Even though all of this technically right now is optional, if you didn't do any of this, you could still answer the question. This gives you a lot of helpful information to be able to find the zeros. So I'm going to start out like we did yesterday, make a table. And you don't have to do this. I'm just going to rewrite the function so I don't have to keep moving my paper up and down. All right. So even though the only number I ever plug in that's not actually part of the list, I still plug 0 in first. And you'll see why. But I still, even though I know it's not going to work, I still plug it in first. So if I plug 0 in for x, my y value is 18. Okay, so then I would consult my list. I'm only trying positive numbers. 1 is on my list, so I'm going to try 1. If 1 was not on your list, which it will be, because 1 goes into everything. If it wasn't on your list, though, you shouldn't try it. So if I plug in 1, so let's see. 2 times 1 to the 4th minus 5 times 1 cubed minus, or plus 20 times 1 squared minus 45 times 1 plus 18. So plugging in 1, you should get negative 10 as the y value. Now, I want to draw your attention to something that happens here. We've talked about this before. When the y values change from either positive to negative or negative to positive, that means for some x value in between 0 and 1, y had to equal 0. So somewhere in between here, y had to be 0. So I'm going to stop here before I plug in 2, and I'm going to look at my list. Are there any numbers in my list that are between 0 and 1? 1/2. So this would make me try 1/2. Now, it doesn't mean 1/2 for sure is going to work, but this tells me 1/2 possibly could work. So that's kind of a clue as to when to try plugging in a fraction, if you notice something like that. And when I plug in 1/2, I can use 0.5 instead of typing in a fraction. So I would have 2 times 0.5 to the 4th minus 5 times 0.5 to the 3rd plus 20 times 0.5 squared minus 45 times 0.5 plus 18. And I do get 0. Okay, if I didn't get 0, then I would keep going with my list and I would try 2 next, and then 3, and then 6, and so on. So since I did get 0, what did we do yesterday after we found a number that worked? Yep, synthetic division, and again, this is your R value. You don't change the sign from it. So I'm going to do synthetic division with the R value positive 1/2, or if you wrote 0.5, that's fine. Make sure with your coefficients, if you're missing any, you fill in zeros. So I have 2, negative 5, 20, negative 45, and 18. Bring down the first coefficient of 2. And then do the synthetic division. So 2, remember when you multiply by 1/2, you're really dividing by 2. So 2 times 1/2 is 1, plus negative 5 is negative 4. Negative 4 times 1/2 is negative 2, plus 20 is 18. 18 times 1/2 is 9, plus negative 45 is negative 36. And negative 36 times 1/2 is negative 18, plus 18 is 0, and your remainder should be 0. Okay, so now what I'm left with as a quotient, I started with x to the 4th, so I now have 2x cubed minus 4x squared plus 18x minus 36. And now I'm really solving that as if it was equal to 0. This is the equation I'm now trying to solve. Okay, and to solve this, I can either keep going, keep trying values from this same list, or I can use other methods that we've learned if they work. So when we get to this point, I think I mentioned in the example yesterday, what is another technique that could possibly work to solve this? Yeah, the grouping, and it takes some practice to be able to recognize when you think it might work, but typically when I get to here, I would at least try and see if it works, because then it's less guess and check you have to do. So if I tried grouping, what do the first two terms have in common? 2x squared. And if I divide them both by 2x squared, I get x minus 2, not minus 4. X minus 2. Okay, and then what do 18x and 36 have in common? 18. If I divide them both by 18, I get x minus 2. So here, because the parentheses are the same, grouping actually works, meaning I don't have to do any more of the guess and check with the tables. So to finish factoring this, I have x minus 2 times 2x squared plus 18 equals 0. And I just need to solve this by setting both of these equal to 0. So I have x minus 2 equals 0, or 2x squared plus 18 equals 0. For the first equation, solve for x, add 2 to each side, x equals 2. For the second equation, I need to get x alone, so subtract 18. 2x squared equals negative 18. Divide both sides by 2. X squared equals negative 9. And then take the square root of each side. And x would equal what? Yep, 3i plus or minus. So positive 3i or negative 3i. Okay, and we're done. So here you just have to not make me search for your answers, because if I can't easily see them, you might lose points. So list out the zeros, and we should have 4. Our first one we found was 1/2. And then we have x equals 2. And we have positive and negative 3i, and you can write that as plus or minus 3i, or you can separate it into 3i and negative 3i. Either way you write it is fine with me. I just need to easily see what your 4 answers in this case are. Okay, are there questions on that?